and good evening. कैसे हो? I believe I am audible and visible both. Am I audible and visible? And we have our regular student right here. Priyanshu, you are 12th pass. Audible, visible, perfect. And I have got 12 likes already, and I have 6 waiting. So, audible and visible both? Great. So, today we are going to start with a new chapter. And before that, I'll tell you one thing very important. What I have got is that tomorrow we are going to have 6 hour classes. We are going to have a class at 10 a.m. tomorrow, and that would be of thermodynamics. We are going to have a class at 10 a.m. tomorrow that is going to be containing all things like the chemical thermodynamics we are going to do thoroughly, completely. And the tomorrow itself, in the evening, we are going to have the third law of thermodynamics and the Gibbs free energy. So tomorrow we are going to finish off with complete thermodynamics. Some person has left the group. Okay, so we shall be having the class tomorrow, 2 classes. Everybody is clear with that? Very great. Okay. So to begin over with, today we are talking about chemical kinetics and chemical thermodynamics. It's a very unique combination that we are doing chemical kinetics and chemical thermodynamics both together. This is a rare and a very unique combination because thermodynamic and chemical kinetics, they complement each other. What is being done in thermodynamics, that is not being done in kinetics. Okay, and what is being done in kinetics, that is not being done in thermodynamics. But if you join the two, everything is being done. So thermodynamics becomes an extremely important part. Is this clear? Wow. So everybody ready for Ritik? We every day have a marathon only. We are having only the marathon sessions. We have nothing else. Only the marathon sessions we have every day. Clear? The only thing is tomorrow it's going to be a super marathon. 6 hours. So ready for it? Great. So let's begin over with the chemical kinetics. And today we are having just my introduction, my name, my qualification. You everybody know it. Not wasting any time with that. So let's begin over with the term called chemical kinetics. और हमने अपने हथियार निकाल लिए हैं. So, ready, steady, and go. Everybody has got the information. Everybody is there. So when we talk about the chemical kinetics, so the topic we have is called chemical kinetics. Now let's talk about what chemical kinetics deals with. Okay, I'm not going to go into the history of chemical kinetics, that it has come from kine, that is movement, motion. No, we are simply going to talk about the chemical kinetics. What does it deal with? Chemical kinetics deals with the path of reaction, and that means mechanism. Mechanism means how of a reaction. How does a process takes place? Then we are going to talk about the factors affecting the rate of reaction. Do you know, when I teach without the presentation, then in that case, I am teaching with the 26 years of experience that I have. Presentation, they guide. But without the presentation, it's me and you. We are taking it. Piyush, if you want, you can take the notes again, and I would really appreciate that if you make the notes now, because these notes are going to be something which are really going to help you. I hope all the students who have been taking the notes, they have a real nice time completing their NCRT. They are able to understand their NCRT much, much better, isn't it? So I would really suggest you to make the notes. Okay, so now what are the factors which are affecting the rate of the reaction? Okay, and further, the kinetics tells you the condition in which reaction initiates. Okay, it tells you when the reaction initiates, what would be the condition under which the reaction initiates, and the most important, it tells you the speed or rate of reaction. These are the things that chemical kinetics does. Okay. Now, we need to know what are the limitations of kinetics. Limitations. And the very first thing is does not tell about feasibility. By kinetic studies, please understand, before you initiate the kinetic study, you need to know the thermodynamics. You need to know whether the reaction will or can take place or not. Unless you know whether the reaction will or can take place or not, you cannot talk about kinetics. What condition it will take place. You first of all need to know whether it will take place or not. Yani ki you need to know the feasibility before you initiate the speed. You need to know whether the car is going to start or not. And after that, only you can talk about the speed of the car. If the car doesn't start, what are you going to talk about the speed? So it does not tell about the feasibility of the reaction, whether the reaction takes place or not. Second, does not tell about the overall energy change. Is that clear? It does not talk about any overall energy change. So that is the restriction. Is this clear? Fine. So these are the limitation of kinetics. Okay. And you need to understand one very thing. Thermodynamics and kinetics are experimental. When I say this reaction is a fast reaction, it is because I have observed the reaction to be fast. If I say this is an exothermic reaction, because I have observed the reaction to be exothermic. If it is a feasible reaction, I have actually seen this reaction happening. If I say this is the order of the reaction, means I have experimentally determined the order to be this. Please remember that thermodynamics and kinetics both are experimental, they are not theoretical. It is not something like we are creating an equation and from that equation we are deriving something. We are not doing that. We are observing it, and that's what we are telling you. Okay, water boils at 100 degrees Celsius. That is not predicted, that is observed. Water freezes at 0 degrees Celsius. It is not predicted, it is observed. Am I clear with that? Okay, so that is what we have as the limitations of kinetics. Now, before we get on with any further thing about kinetics, let's talk about a reaction. Clear? When we talk about something like a reaction, understand the reaction thoroughly. Let's understand the reaction thoroughly. What is the meaning of the word reaction? Here, talking about the word reaction, what it means. Reaction could be something like P of A plus Q of B gives us R of C plus S of D. Okay, so that is what we have. So this is what we have. P of A, Q of B, R of C, and S of D. This is the reaction. Now, what is this? P, Q, R, S are what we call as stoichiometric coefficients. These are the ratios in which the reactants must react and the products to be formed. That is what we get as the stoichiometric coefficients. Stoichiometric coefficients do not tell the actual amount of the reactants and products being obtained. They are actually the ratio. Is this clear? Any doubts? So this is what we have as a stoichiometric coefficient. Okay. Anybody has another network issues? No network issues to be required. You told also earlier that physical, yeah, chemistry is practical. Chemistry is observation, not imagination. So this is what we have PQRS as stoichiometric coefficient. Now, once we have talked about what the stoichiometric coefficients are, just remember left side of arrow is reactant. Right side of arrow is product. Okay. A reaction proceeds forward when reactants are consumed and products are formed. One thing you need to understand is the reactants are being consumed, product have to be formed. It is not something like you keep on removing the reactants and then you say that a reaction is being completed or reaction is proceeding forward. I'm not just saying that the reactant concentration has to decrease. I'm saying the concentration of the product has to also increase. Then only we will be able to say that the reaction is proceeding in the forward direction. Any confusions with that? So that is what we talk about, the procedure of the reaction in the forward direction. That is how the reaction proceeds. Now, once we have talked about whether the reaction is proceeding in the forward direction or not, now we talk about one more thing. We talk about the completion of the reaction. When do we consider the reaction to be completed? Okay. Now, please understand one thing. There is nothing called completion of the reaction. Something like, is there anything called completion of the course? Can you ever say your course has been completed? Can you ever say that you have understood everything, the knowledge has been completed? Can you ever say that your task is all over? हम कहते हैं काम तमाम हो गया या तमाम काम हो गया. That is simply means that a person is over. You always have the work till you live. You always have a target to achieve. Whether you can achieve it or not, it's different thing. But you always have some target to achieve, isn't it? So please remember that there is nothing called completion of the reaction unless you define it. You have to define what the completion of the reaction means. Fine. Now, that completion of the reaction has nothing to do with how much reactant you have, how much product you get. It is up to you. It is just up to you. You define the completion of the reaction. I may say that I would consider the reaction to be completed when 1 mole of A is consumed. Another person say, no, I will consider the reaction to be completed when 1.5 moles of B is consumed. Another person might say that I'm not bothered about how much A and B are consumed. I'm only bothered about how much C I get. I'm going to consider the reaction completed when I get 0.5 moles of C. Another might say, I don't bother about C. I want 1 mole of D. Now, each has defined the completion according to themselves. One might define the completion according to any of the reactant. Another might define the completion according to any of the product. Is that clear? So everybody is bothered about what they want from the reaction, and according to that, they are defining the completion. You may define the completion of the course. There are so many ways to define the completion of the course. One might say that I'm going to say the course is completed when my NCERT books are completed. They may say that. Another person says, I don't bother whether I have to complete the NCERT books or not, are completed, but I would consider my course to be completed when I'm sure I'm going to get 700 out of 720. So one has defined the course, the completion according to the reactant consumption. Another one has defined the completion according to the product formed. But one thing you need to understand, if the reactant are being consumed, the product are being formed. So whether you define the completion as NCERT book completed or you define it as 700 marks obtained, ultimately it means the same thing. If you are going to complete the NCERT, obviously you are going to get the marks in the board examination as well as in the NEET examination. Clear? So once we define the reaction according to any of the reactant or any of the product, everything else is actually defined. Clear? If I say 1 mole of A is consumed, does it mean that B is not consumed? Obviously, B also will be consumed in proportion to the stoichiometric coefficients. Similarly, C and D will be formed according to the stoichiometric coefficient. So it is not a compulsion that I have to define all the reactant and all the product. I can define any one reactant, any one product, and define the completion according to it. Am I clear? Everybody understood? जीते रहो बेटा सागर, कैसे हो? मराठी मुझे नहीं आती बेटा, लेकिन आपकी बात मुझे समझ में आ रही है. शुभ संध्या काल जी. दैट इज कॉल्ड गुड इवनिंग. जीते रहो. अमान हुसैन बेटा, इस सेशन में भी फिजिक्स वाला. इज दैट क्लियर? Okay, so am I clear with what is the meaning of completion of the reaction? So completion of the reaction is when any of the reactants specified amount is consumed or a or specified amount of a product is formed along with the required amount of other reactants and formation of corresponding amount of other products given by a balanced chemical reaction. Reaction means equation. So if this is done, we consider the reaction to be completed. We are not bothered about whether other reactant is left or the product is left or the product is formed more or whatever is required. Okay. Now let us say I say that the reaction is completed when 1 mole of A is consumed and I have only 0.5 moles of A. Now the reaction will never be completed. Forget it. It will never be completed because I didn't have the required amount of A. Clear? You say that I'll consider the course to be completed when NCERT books are completed and you don't have NCERT book. Your course will never be completed. Is it clear? Am I clear? Okay. Now we need to understand one very important thing. We have talked about the completion of the reaction. We can even talk about not the complete completion, but rather the partial completion of the reaction. Let us say half completion of the reaction. Half completion of the reaction. Okay, I'm saying the reaction is half completed. Now, before I get along with the reaction being half completed, I need to understand what is the meaning of half completion. Now, before I go on with that, I'll ask you a very simple question. Very simple question. And the question is, a person takes 1 hour to dig a hole. Okay. How much time he needs to dig half hole? Answer. Give me. How much time will he take to dig half hole? Ananya Sarkar says it's impossible. How is it impossible? What do you mean by impossible here? Ananya Sarkar says question ही गलत है. Piyush says half hour. But how much he dig? Anything you can consider. 1 meter, 2 meter, 3 meter, 10 meter. You may consider anything your wish. I'm just asking you how much time will he take to dig half hole? Answer. राधिका मित्तल says half hole तो कुछ होता ही नहीं है, वो तो एक ही होल माना जाएगा. Yes, you are right. Half hole जैसी कोई चीज होती ही नहीं है. There is nothing called half hole. Whatever you dig, that is a hole. It may be a small hole, it may be a large hole, it may be a super large hole, and it may be a super small hole. But again, everything is a hole. There is nothing called half hole. Is that clear? So there is nothing called half hole. The question should have been a person takes 1 hour to dig a hole 1 meter deep. How much time he needs to dig a hole half meter deep. Please remember, both are one hole. In the same manner, there is nothing called half reaction. A reaction is half in comparison to complete reaction. Before you define the half reaction, you have to define complete reaction. Then only you can talk about half reaction. Okay. So half completion is the reaction is half completed when half the specified amount of reactant is consumed or half the specified amount of product is formed. Okay, clear? So that is what we have as the half completion. Obviously, the required amount of other reactants also will be consumed and corresponding amount of other products also will be formed. Is this clear? Fine. Masuda, did you hear what I said? No, you didn't. Clear, Ananya? Okay. You said it's impossible, but you need to tell me why it is impossible. Because ऐसी कोई चीज exist करती नहीं है. So that is what we have as the half completion of the reaction. So let us say we again talk about the same reaction that we talk about. P of A plus Q of B gives us R of C plus S of D. The reaction would be considered completed. Now the stoichiometric coefficient are giving me a kind of the idea, okay, fine, I want P amount of A to be completed, consumed. Clear? Okay. So we are talking about the P amount of A to be consumed. So when we talk about the P amount of A to be consumed, it is going to be like, this is the stoichiometric coefficient. Okay. So this is the amount that I have defined to be completed. Then I have the Q amount of B to be consumed. Okay. So if we have P amount of Q to be P A to be consumed, Q amount of B to be consumed, R amount of C to be formed, S amount of D to be formed, I'll consider the reaction to be completed. So the stoichiometric coefficient tell me the amount which I expect to be consumed. Okay. ठीक है ना. अशरफ पठान, क्या समझ में नहीं आ रहा बेटा, ये तो बता दो. आपने अभी ज्वाइन किया है क्या? I said the reaction will be considered completed when P moles of A, Q moles of B are consumed. I don't know whether they are present or not. I don't care. I have defined it that way. R moles of C and S moles of D are formed. That is my definition of completion. Okay. When the reaction gets completed, we say it is completed and completion is one. Okay. So we define something called advancement. For completion, advancement is 1. When the reaction gets completed, advancement is 1. Ritik solution, I am not able to attend your classes, sir, after 5 p.m. because I have lots of work. मैं आपका record session attend कर लूंगा. Fine enough, it's your wish. Clear? But I will sincerely wish that, okay, whenever you have the recorded session also, then also you'll have to spend some time. Why not in the live class? Maybe you want to work. Masuda Shoaib, network issue. Okay, fine. Now for completion, advancement is 1. That you need to understand. Or what we do is we call it 1 mole per liter. Just like that. We have given the advancement in the units of concentration. You may say 1 mole, you may say 1 gram, you may say 1 kilogram. So you need to define the advancement. You have to give some unit to it. Your wish. So completion, the advancement is 1 or 1 mole per liter. Now we can have partial completion. Partial completion. When we say partial completion, what would that mean? Partial completion would mean, let us say partial completion is X. X is what? Fraction of reaction completed. Okay. So if 1 is the reaction, then P moles are consumed or P mole per liter is consumed. But if the the fraction is X, then Px of A consumed and Qx of B consumed, okay, Rx of C and Sx of D are formed. Is this clear? Ananya, for half completion, it is P by 2. Why is it 0? Ritik, from tomorrow we are going to have morning classes as well. Did I not tell you that tomorrow onwards we are going to have the class at 10 a.m. also? Okay. And if everything goes right, we are going to shift the classes to 10 a.m. only. Clear? So Munna, today you are here. Great to be here. Clear? So when we talk about the partial completion of the reaction, the fraction of the reaction completed, Px of A, Qx of B, Rx of C, Sx of D. So that is what we have as the partial completion of the reaction. Okay. Anyone has any kind of confusion in completion of the reaction, half completion of the reaction, partial completion of the reaction? Jyotiraditya Vara, yesterday at 8 p.m. we discussed about this. What is the best books in chemistry? Go ahead and see the session that we had yesterday at 8 p.m. Okay. Anyone has confusion about any of these? Half completion, completion. Now I have a question. For the reaction, P of A gives product. P of A gives product. Initial concentration of A is A naught. Okay. Full stop. Px concentration is consumed. Okay. Initial concentration of A is A naught. Px concentration of A is consumed. Okay. What is the change in concentration of A? बहुत ही घटिया सवाल है, बहुत ही वाहियात सवाल है. Just tell me what is the change in concentration of A. And just इसमें भी मैं आपको hint दे देता हूं. I just give you a hint in that. Change is final minus initial. Okay. Now tell me what is the change. Yeah, Ananya. Advancement means the fraction of the reaction completed. Advancement is a dimensionless quantity as such, but we have given it a dimension of moles per liter. And the maximum advancement is 1, minimum is 0. Negative नहीं होता. So can anybody tell me what is the change in concentration of A? And change is final minus initial. Tell me. Option. इसमें भी. Tell me the option. यार इसमें दिक्कत क्या है? Option चलो कोई नहीं. A option is A naught minus Px. B option is Px. C option is A naught minus Px by A naught. D option is minus Px. E option is none of these. Okay, give me the option then. नहीं तीर्थराज, आज हमने 8 PM पे कोई स्पेशल क्लास नहीं रखी है. We will put it, but we don't have any questions for the special class for today. So most of the students have got the right answer. Here we have change. Initial amount is equal to A naught. Initial amount is A naught. Consumed is equal to Px. Remaining is what we call as final. And that's A naught minus Px. Clear? So the change will be equal to A naught minus Px minus A naught, and that's equal to minus Px. Anybody has any confusion here? Why we have the value as minus Px? Any confusions? I don't know why the students say मेरा नाम ले लो, मेरा नाम ले लो. क्यों ले लूं? नहीं लेना. You are blocked. Please remember this class is a very serious class. Very, very serious class. I have very few students in this class. And because I have very few student class, I am very picky. Anybody disturbing the class, blocked. Piyush, just block the person. I have already blocked the person, but it's blocked from my side. You also need to block from your side. Since I don't have admin rights, I cannot block it forever. Okay, so just remember that. So what we get? We get that change in concentration of any reactant is negative and in product is positive. Clear? So when I talk about P of A plus Q of B giving us R of C plus S of D, then the change in this is for the X advancement. This is going to be minus PX. This is minus QX. This is going to be plus RX and this is going to be plus SX. Is this clear? Any confusions here? Okay, so that's what we have as change in concentration of any reactant and product. So concentration change in any of the reactant is negative and the concentration change in any of the product is positive. Now let's talk about the rate of change. Rate of change. Now, rate of change, if we talk about instantaneous, that would be the differential. We'll be talking about the differential. Clear? So, we are going to talk about the rate. That is going to be change in concentration divided by change in time. Change in concentration per change in time. Clear? So let's talk about the rate of change of concentration. Clear? So we are going to talk about each of them, each of the reactant, each of the products. So let's say we talk about dA by dt. Any confusions here? ROC, rock. What exactly is rock? dA by dt. Now dA by dt is change in concentration of A per unit time. That is rate of change of concentration of A. So this is Rate of change of concentration of A. Clear? So now this is d of minus px by dt. Any confusions here? कोई confusion? समझ आ गया ना? Because minus px is the change in concentration of A. That's we have already discussed. Now p is the stoichiometric coefficient, so it is constant. So it comes out to be equal to minus p dx by dt. So that is what we have as rate of change of concentration of A. In the same manner, if we talk about dB by dt, that will be equal to d of minus qx by dt, and that will turn out to be minus q dx by dt. Anybody has to ask anything? Now then we can have dc of by dt. Now that will be equal to d of plus rx by dt is equal to plus r dx by dt. And then we have d of d by dt. That's equal to d of plus sx by dt is equal to plus s dx by dt. Medico Masidul Chaudhary. Yes, beta. My plus course is going to start from 1st of August. So from 1st of August, we are going to start with the plus batch. Okay, fine. Now, I can get one thing very clear. This would imply dx by dt is equal to minus 1 by P dA by dt. Clear? So what I get is dx by dt is equal to minus 1 by P dA by dt, which is equal to minus 1 by Q dB by dt, which is equal to plus 1 by R dC by dt, which is equal to plus 1 by S d of d by dt. Till here, anything anybody to need to ask? I'm not talking about easy or difficult. I'm talking about have you understood it? Wow. Now this dx by dt is called rate of reaction. Dx by dt is called rate of reaction, and this is what we have written is called differential rate law. Okay. So now let's define what is rate of a reaction. Rate of a reaction. Rate of reaction is the rate of change of advancement. Rate of change of advancement, which is the same as the rate of change of concentration or amount or whatever you wish to call it of any of the reactant or product divided by their respective stoichiometric coefficients. Okay. Now, one thing is very important. These coefficients are negative for the reactants and positive for the products. Anyone has to ask anything here? Kalpana Yadav, welcome, beta. Manish Gurjar, welcome. and I have my own 6 students now. I hope you have already joined that website and you have already started attempting the questions. Okay. And now you can understand that the rate of reaction changes with the stoichiometric coefficient, that is balancing of the reaction, because you change the initial or specified amount. Clear? Your rate of completing the course actually changes if you change the target. You have completed one chapter of the book. Your target was 12 chapters. So you have done 1/12 of the course. But if you make the target as 30 chapters, then in that case, one chapter would become 1/30th of the course, and your rate would actually be slower. समझे? Fine. Jyotiraditya, my writing can't be improved, but I'm dictating you. I think you can write with my dictation. And since I'm getting excited, my writing is going to become even bad, worse. So you need to hear what I say. And if you feel like you are not able to understand what I'm writing, ask me. I hope it is legible. You can read through it. I don't say it is beautiful, but it is legible, readable. Okay, so that's what we have as the rate of the reaction. So we have just defined what is rate of the reaction. So मैंने join किया. I know you have joined. I have already given you the access to all the courses. Okay, now you can attempt the questions. There are so many questions. Okay, so that's what we have as the rate of the reaction. Clear? Now, it is not necessary that we have to talk about instantaneous rate. We have got what we call as differential rate law. Okay. Now, could you write the differential rate law for this particular reaction? N2 plus 3H2 gives us 2NH3. So rate is equal to dx by dt, which is equal to, could you just write it? Ram Bhakt, this is an English medium class. This is an English medium channel. Okay. Don't spam. Clear? Answer. Now that's going to be minus dn2 by dt is equal to minus 1 by 3 dh2 by dt is equal to plus 1 by 2 NH3 by. Is this clear? Just a minute. Okay, let's have a look at the NCRT. Wow, Radhika Mittal. You already predicted that I'm going to do NCRT now. Yes. So have you read this? Have your NCRT with you? Open up your NCRT and just have a reading through it. Any point that you have not understood till now? Well, this particular introduction is not very important, but yes, you can read through it. Read, 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 read till here. Read through it. Read it. So rate of a chemical reaction is here. Read through it. I hope you are able to understand whatever is written here. Now, this is something what we can call as the average rate within a given time interval. There's one thing called instantaneous, another one is called average. Read it? Anyone has to ask anything? Or is it getting clear? I hope now this graph also is very clear to you. Anything you want to ask? Now we are going to do just the units of rate reaction. I'll just tell you what the units of rate of reaction would be. So when we talk about the units of rate. Now X has the unit of mole per liter, and T has the unit of maybe seconds. So rate will be having the unit of mole liter inverse second inverse, or you can say it would be concentration inverse time inverse. Any kind of doubts? Priyanshu Ghosh, reactant concentration decreases, but with time it decreases sharply. It depends on how much time interval we are talking about. And that sharpness is not for every reaction. For some reaction, it might be very slow. It is just a depiction. Am I clear, Priyanshu? It is just a depiction. It's not a specific reaction we're talking about. Clear? So, just go through the question, example 3.1. Any doubts you have? Any doubts? Are you able to understand this table? Read it thoroughly and nicely. Mole a little bit. Piyush, what exactly you want to know about mole? Mole is simply an amount. That's it. Like kilogram, like grams, like milligrams, like liters. We talk about moles. Can you read through it? You are reading through your NCRT? You can read through till this point. Index question 3.1 and 3.2. No, we are not going to complete it in one shot. It can't be. But we are going to finish it off in two shots. The after tomorrow, we are going to finish off with chemical kinetics. Take your time, take your time. I'm not in a hurry. Anyone has any kind of confusion till here, or you have read through it? Inform me. You have read it or not? Any doubts? Anyone? Any point? Anything? Well, it seems we are going quite fast. These writing and the marathon sessions, they actually complete the sessions quite easily, and then we have the NCRT reading also, so I don't think we are leaving anything. Clear? Does anybody have to ask anything? Fine enough, then you can take a 3 minute break. Have a 3 minute break and quickly come back to the class. 3 minute break. So we are having a hmm, 3 minute break over at 5:24. 3 minute break, 5:24, it would be over, and then we are going to have the break at the end of the class only. Okay, we begin. So, we begin over with it. Now we talk about the factors which affect the rate of reaction. Now we are going to talk about the factors which affect the rate of reaction. Now let's proceed. Everybody here? Okay. There are many factors which affect the rate of the reaction. The first one being concentration of react. Now, we could have concentration of the reaction or we may have the pressure of reactants. If we have the gases, now this is for solution and this is for the gases. Okay. Then second, third, we have the nature of reactants and products. The nature of reactants and products. Please remember the rate of the reaction depends not only on the reactant but it depends on the products as well. Then we have something called catalyst. Then we have temperature. Then we could have something like radiations. And a very important part is what we call as the solvent. One thing you need to understand that each and every reactant is not going to have all the factors. Some reactant might not be affected by radiation. Some reaction might not have a solvent. Some reactions, something like nuclear reactions, they are not affected by temperature. Photochemical reactions are not affected by temperature. And some reactions don't have a catalyst. Clear? So it is not necessary that every reaction is going to be affected by everything. But if the rate of the reaction is changing, it is going to change by the change in one of these things. So that is what is important. So that is what we have as the factors which affect the rate of the reaction. Okay. So now let's talk about the various factors separately. The first factor that we talk about is called the solvent. Solvent. What is a solvent? Solvent is the component present in a huge excess Solvent is the component which is present in a huge excess so that a small change in its concentration does not affect the rate of reaction. Okay. So solvent is the component present in such a huge excess that a small change in its concentration does not affect the rate of reaction. It is something like that. Let's say we talk about you taking an exam in a particular examination hall. So will the number of students sitting around you and the oxygen around you affect your marks unless we actually drastically reduce the amount of oxygen by some reason? Hmm? राधिका मित्तल, एक्सेस, एक्सेस नहीं. Access means to be approachable. Approach. Excess means large amount. Don't mix up. Excess. Clear? Sorry. I'm not supposed to correct your English, but can't help it. I'm a teacher. I find a mistake, I have to correct it. Okay? So, solvent. Clear? Now, solvent is an important part of the reaction wherever it is present. Now, solvent could be solvent may be reactant, product, facilitator. Facilitator is something like we are having ionic reactions, then water behaves as a facilitator. It is not taking part in the reaction, it's not getting reacted, it is not being consumed, it's not being formed, but without water, the reaction is not going to take place. Or simply inert medium. Okay. Solvent is not mentioned in rate equation. We do not mention the solvent in the rate equation because the rate does not depend on solvent. Okay, it does depend on the solvent, but it does not change with the concentration of the solvent. Clear? So that's what we have as what we mean as a solvent. Now, having talked about the word called solvent, we have another word, and that is what we have as the nature. Now, nature of reactant as well as product affect the rate. Okay, the nature of the reactant as well as product affect the rate. And how does the product affect the rate? I believe we have already done those questions. I believe you would be knowing it. Like if we have calcium, or rather I should say, we have barium carbonate, and we reacted with dilute sulfuric acid, that should give us barium sulfate and carbon dioxide and H2O. But now the barium sulfate which is being formed is insoluble. Barium sulfate which is being formed is insoluble. And being insoluble, the barium sulfate, it attaches or it covers the surface and stops the reaction. So here, barium sulfate being insoluble is going to actually stop the reaction. Clear? Okay. That's one reaction. Another one reaction is like we have aluminium reacting with HNO3. Now, when aluminium reacts with HNO3, it actually forms aluminium oxide, which prevents further reaction. Okay. And then there's another reaction. We have KMnO4 reacting with oxalic acid in presence of an acid to give us Mn2 plus CO2 plus H2O. Now, this Mn2 plus, which is being formed in the reaction, is actually a catalyst for the reaction. So the reaction becomes faster as it proceeds. Now, these reactions are called auto catalyzed reactions. Reactions in which product is catalyst. Fine. So we have just talked about the auto-catalyzed reactions. Fine. Now, having talked a bit about the nature of the reactant and products, now we talk about, let's say, concentration and pressure. Concentration and pressure. Okay. So let's talk about the concentration and pressure. Now, concentration and pressure both mean the number of reactant molecules per unit volume. So whether we talk about the concentration or we talk about the pressure, it means the number of reactant molecules per unit volume. If you increase the concentration, if you increase the pressure, you are increasing the number of reactant molecules per unit volume. So as the number of reactant molecules increase, with increase in concentration, the collisions amongst reactant molecules increase. Clear? With increase in concentration, the collisions between the reactant molecules increase. Fine. Now, whenever the reactants collide with each other, there is a chance of reaction. It's not necessary that the collision will always lead to a reaction. It is not necessary that if a boy and girl they collide, they have to marry. It's not that way. But more and more boys and girls meet, the chances of marriage increases. Am I clear with that? Okay. So as the number of collisions increase, the chance of collisions taking place, the chance of reaction taking place would increase. Okay. So with that, the rate of reaction increase. Is this clear? So the rate of the reaction increases with increase in the concentration of the reactants. Increase in concentration, you may say, or increase in partial pressure of the reactants. Is this clear? Fine. Now we have something called a law, and that law is called the Goldberg and Vajay law. In Hindi, we write it Vajay law, or we can call it Vage law or Vague law, your wish. And that is also called the law of mass actions. Before we get along with the law of mass actions, we talk about something called the active mass. Active mass. Now, the active mass is actually a factor on which the rate of a reaction depends directly. A factor on which the rate of reaction depends directly. That is what we have as active mass. Or you can say the factor which actually influences the reaction or participates in the reaction. Okay. So you may say the factor which actually participates in or influences the reaction. Is this clear? So that is what we have something called the active mass. Now, active mass mostly is determined by raising the concentration of the reactant with certain number. Okay. Active mass is equal to concentration raised to power a certain number. Let's say n. Now, this n is called the order. Okay. Active mass is concentration of the substance raised to power n, and n is called an order. Order is any real number. Order is not an imaginary number. Order is any real number. It could be 1, 2, 3, 4, minus 1, minus 2, minus 3. It could be 0. It could be 0.5, 0.25. It could be pi. It could be anything. It could be any real number. Rational number, irrational number, allowed. Is this clear? So that is what we call as an order. Order of the reaction. Fine? So order is any real number. Nth order could be anything. Now, one thing more. Order is always experimentally determined. Order is always experimentally determined. Okay, it is never predicted. It is never predicted from the equation. Okay, has no relation with balancing of equation, or you may call it stoichiometric coefficient. So it may be equal to them, it may be not equal to them, you can't predict it. So order is any real number always experimentally determined. It has no relation with the stoichiometric coefficient. So that is what we have as order. Yeah, Tirthraj Mukherjee, anything you want to ask here? Real number which exists, which are not hypothetical, not imaginary. So we are not going to talk about that iota. Clear? Now, Goldberg and Waage law simply states the law of mass action or law of active masses. So Goldberg and Waage law, that is what we call as law of mass actions, which is a very important law for equilibrium, says the rate of a reaction is directly proportional to the product of active masses of the reactants. The rate of a reaction is directly proportional to the product of active masses of the reactants. Clear? So when we have the equation like P of A plus Q of B in giving us C, R of C plus S of D, then in that case, rate of the reaction is proportional to A raised to power alpha into B raised to power beta. Alpha and beta are the order with respect to A and order with respect to B. Okay. Alpha plus beta, which may be written as N, is the overall order of the reaction. Okay. Alpha plus beta equal to N is the overall order of the reaction. And alpha and beta could be anything, could be positive, could be negative, could be zero. Okay. So A raised to power alpha would be active mass of A, while B raised to power beta would be active mass of B. Noted it down? Anything to ask? Anyone has to ask anything here? Fine. So that is what we have as the rate of the reaction. Now, as we can see that rate is equal to, or rate is proportional to concentration of A raised to power alpha, concentration of B raised to power beta. To make it equal, I need a constant. Proportionality converted to a equality, we need a constant. So we get it as rate, and in chemistry, we just simply talk about constant as K, because in Greek, no, in Latin, constant stands with K. So K into concentration of A raised to power alpha, concentration of B raised to power beta. Now K is what we call as the rate constant. We can call it the velocity constant, or we can call it as the specific rate. Now, what do we call it specific rate? Now, this rate constant is defined as the rate of the reaction when concentration of each reactant is unity. That is, we can consider as A as 1 and B as 1. So rate is going to become equal to 1. Rate is going to become equal to K. So that is what we have as the rate constant. Anyone has to ask anything here? What is the meaning of rate constant? Yeah. Okay. Now let's talk about a very important factor called dimensions of rate constant. Dimensions of rate constant. Talking about dimensions of rate constant, we have rate is equal to K into concentration of A raised to power alpha into concentration of B raised to power beta. Now, rate has a unit of concentration time inverse. Now, that would be equal to K. Now, A has a unit of concentration. So, this is concentration raised to power alpha. Now, B also has a unit of concentration and that raised to power beta. Fine. So, what we find is that the unit of this would become concentration into time inverse is equal to K into concentration raised to power alpha plus beta, and we know alpha plus beta is equal to n, which is the overall order of the reaction. So that would turn out to be K into concentration raised to power n, and what we get, K would be equal to, now I just twist it around, concentration raised to power, now concentration divided by concentration raised to power n time inverse. So that would become equal to concentration raised to power 1 minus n time inverse. Anything you would like to ask here? This derivation, a simple, very simple derivation. Okay, so let's have a few questions. Question. If concentration is in mole liter inverse and time in seconds, find find the unit of rate constant of A, zero order, B, first order, and C, second order reactions. Give me the units of the first order, second order, and zero order reaction. If it's clear, Radhika, Tirthraj, give me the answer. I need the answer here. Give me the unit of rate constant, Tirthraj. I didn't want the zero order reaction. What would be the unit? When we talk about the zero order reaction, n equal to 0. Okay. Now, K is equal to concentration raised to power n, 1 minus n time inverse. That will be concentration is mole upon liter raised to power 1 minus 0 into second inverse. So it is going to be mole liter raised to power minus 1 second inverse. So this is the unit of rate constant for a zero order reaction. Any problems? Okay. Ananya Sarkar, second inverse for the first order, perfect, not a problem. And mole inverse liter, second inverse for the second order reaction. Perfect. Yeah. So let's have a look at NCRT now. There are certain questions that you are supposed to do. I hope these questions are done. Just read through it. Read it? Read through it. Anyone has to ask anything here? Any kind of doubts here? Harshvardhan Dhirange. Hello, beta. Have you read it till here? Now we are going to talk about how to find out the rate of the reaction later. Can we talk about the example 3.3? Anything you want to ask here? Now, this question was there in the NEET 2023 exam. It's difficult to refer to NCRT every time because NCRT has a tendency to go haphazard. Okay. So here we have this question we have just done. Any doubts? Okay. Have you read this question? Have you read this question? Okay. Anything to ask here? We will end the session today itself, today here itself. So these are our lock, the biggest offers and 25% off on all Plus and Store subscriptions. You can use the code AV Live and join with us. And tomorrow be prepared, we are having a class at 10 a.m. Got it? So we have the class at 10 a.m. of thermodynamics. Clear? We are starting over with chemical thermodynamics. So we have iconic mega cell weekend, 25 plus 15. 2 p.m. we have the botany class with Swati Batra ma'am. 3 p.m. we have the 4 p.m. Class with Sachin sir. 4 p.m. we have the class on chemistry with me. And tomorrow we have a 10 a.m. class with chemistry. Is this clear? So tomorrow just tell Piyush, we are going to have the session on solid state. Let us finish off this part first. Okay? We'll get it. Join our Telegram channel for YouTube classes on PDF, t.me/neet elixir. And I believe you are making your notes, so you don't need the notes to be given to you. Iconic and plus, join with us. Unacademy app, select your goal. Unacademy.com/Anoop Vashishtha is my page on Unacademy. I believe you have already joined it and followed me. So subscribe to the Neet Elixir by Unacademy for best live classes. We shall meet tomorrow in the morning. Thank you. Bye bye. Take care.